Okay, so this is just a quick recap of work excuse me, done in class on finding a rule for a number pattern. So for example, 5, 8, 11, 14, what is the next number in the sequence? Now it's obvious that the next number in the sequence is 17 because you're adding 3 each time. The 10th number of the sequence you could easily find by just keep adding some more 3's until you've got to the 10th one. But the 1000th number in the sequence, you don't really want to have to do that because you don't want to have to work out the previous 999 in order to work out the 1000th one. So it would be a good idea to have a rule that took us directly from the number 1000 to the 1000th term without having to work out all the previous terms. So that's what this is all about. So if we think about the positions in the sequence, 1, 2, 3, 4, 5, 6, and then the term that holds that position, so 5, 8, 11, 14, 17, 20. So if the position is n, then when n is 1, the nth term is 5, because the first term is 5. When n is 2, the nth term is 8, because the second term is 8. When n is 3, the nth term is 11, and so on and so on and so on. So looking at this table, you can see that every time you go up by 1 in the sequence, then the numbers go up by 3, because we know that in this rule the numbers go up 3's every time. So every time n goes up by 1, the nth term goes up by 3. So that gives us a clue about the rule. It tells us that the rule for the sequence must somewhere involve 3 times n. Now, if we think of a term, or if we think of the rule just being 3 times n, then these are the numbers we'd get. So if n was 1, 2, 3, 4, 5, 6, then 3 times n would be 3, 6, 9, 12, 15. But actually, the numbers we want to get are not 3, 6, 9, 12, 15. We want to get 5, 8, 11, 14, 17. So by having a rule that says 3 times n, we've achieved a sequence that goes up by 3 every time. But it's not the right sequence that goes up by 3 every time, because the sequence we want is 2 higher every time. So when we wanted 5, we only got 3. When we wanted 8, we only got 6. When we wanted 11, we only got 9, so on and so on and so on. So the rule isn't actually 3n, but it's 3n plus 2. So if we have the rule 3n plus 2, then we get the numbers we want, 5, 8, 11, 14, 17. And now that we've got a rule, 3n plus 2, it's easy to work out what the 1000th term is, because you can just stick 1000 into that formula and get 3002. So the 1000th term of that sequence would be 3002, and we didn't need to work out the previous 999 terms. So here's another example, 16, 18, 20, 22. The numbers go up by 2 every time, so that gives us a clue that the rule has got 2n in it. Okay, so these are the n's, the number in the sequence, the position in the sequence, 1, 2, 3, 4, 5, 6, 7. These are the terms we want, 16, 18, 20, 22, and so on. So if we just do 2 times n as the rule, because it goes up by 2 every time, we only get 2, 4, 6, 8, 10, 12, 14. The numbers we want are 14 higher than that, so our actual rule is to take that and add 14. So our rule is 2n plus 14, and then when we do 2n plus 14, we get the numbers we want, 16, 18, 20, 22, 24, 26, 28. So the rule is 2n plus 14. And now that you've got a rule, it's easy to figure out the 1000th term. There's another one. You can just pause it, have a look at it, try it yourself without looking at the answer first. And there's another one still. It's been done by kids during the lesson, students during the lesson, I should say, so that's why it's a bit messy. So have a go at those without looking at the answers. another one there. Just kind of cover up the screen, have a go at it first. And another one. So just have a go, cover up the screen, pause it, and see if you can do it without looking at the answers. One more there, and video ends now.